Okay, so one quick question here, just going through what would I want to see on a test if we're graphing sinusoidal functions. What I'm interested in knowing really is, do you understand what these four values do to our original sine curve? Okay, so sort of if we think about this as the parent curve or the original curve, what changes are made to this by having these numbers? So if I'm doing this, the least important thing as the teacher looking at the final answer is what the graph looks like. You could easily pull up a graphing calculator or an app on your phone, obviously, to draw the graph. So really what I want to see, even if the question says graph the following, is show me that you know what these various numbers mean. So kind of in setting up the question, I'm going to just kind of make a list of what the numbers, sort of give me. The amplitude is 12. Okay. And in case you don't remember, the amplitude is when we look at a sine curve, it's the distance between the axes of symmetry and the top of the curve, the maximum value. Also, obviously, between the axis of symmetry and the minimum value. So that's the amplitude. You don't have to draw the diagram. That's just kind of to help out. So I state that the amplitude is 12. The number 3 right here tells me that there are 3 cycles in 360 degrees or in 2 pi, which means that the period, so the length of one cycle, is 2 pi divided by that 3, which obviously in degrees is 120 degrees, but we're working in radians for this question. The last two terms here, I guess I can kind of summarize in one step. What does this tell me? Don't forget about the minus sign. The graph is going to shift. Oops. The graph is going to shift right 90 degrees, pi over 2, and up a distance of 8. Okay. So now when it comes to actually drawing the graph, this is the information I'm going to display. In the previous video, I showed kind of, with a grid, fitting it to the grid. But I think maybe an easier way to do this is actually draw the curve first and fit the grid around it. So in this case, I know there are 3 full cycles in 2 pi. Typically a question would say sketch at least 1 cycle. In this case, I think 3 cycles might actually be easy for me. So let's see how well I can do here. Okay, so that's kind of 1. And then let's just take advantage of what I have here. That didn't work. So again, in this case, I think because of the technology and the tablet I'm working on, 3 cycles might be nice and easy to draw with the copy and paste in this case. Obviously, for you to draw it on paper is a little bit easier, nice smooth 3 curves. And then pretty much you want to fill in the information that you've got here. I recognize that I've shifted pi over 2, so I can kind of take that into consideration. So I guess if I shifted it to the right pi over 2, that means that right here, my starting point is pi over 2. And then sort of each cycle is a distance of 2 pi over 3 further. Now if I go sort of that extra step and say, well, where am I? Right over here on the end. 3 full cycles take up 2 pi. So this is 2 pi plus another half of a pi. So 2 pi plus another half of a pi, which is 4 pi over 2, 5 pi over 2. and you can kind of go back and fill in values in each of these cases. This was a distance of 2 pi over 3 past the pi over 2. So not super nice to work with, but I've got 4/6 here, and I've got 3/6 here. So this is 7 pi over 6 here. So getting a couple of numbers in, probably good enough. And then I recognize that my minimum value, so I've raised my amplitude was 12. That means my graph would have gone up to 12 and down to -12. But because it's been shifted up 8, I've got a value, that was poorly done, I've got a value of 20, 20 up top, and -12 plus 8, -4 on the bottom. And that's everything. So I could sort of fill in my sketch at that point with sort of fill in the grid. My zeros right around here. My zeros, excuse me, my zeros over here. Whoa. So my graph more or less looks like this. I've got 20 as my maximum, -4 is my minimum, starting at pi over 2 and going the waves out. Now, as we said last time, we obviously, once we've got that information down, if we had a new grid, nice clean grid, we could do a kind of proper final answer. This would be kind of our rough draft, but it's got all the information I want, all the information I need, provided you've got these things indicated at the top. I can clearly see that you knew exactly what you're doing in those cases, and now I can see that 20 and -4 are the key maximum minimum values. Pi over 2 is my starting point, and you knew that sort of some points along the way, doing a little math could get you there. Okay, so I think that's probably a good place to stop that one. I'm going to pause and come back in a second. Okay, so look at a second example here. This one's going to be a little different only in the sort of the actual graphing, and we'll see why momentarily. So again, I'm looking at this question, and what I want to make sure that my marker knows is that I understand what each of these values does. So I recognize my amplitude is 4. I recognize that I have half of a cycle. In my 2 pi, which means that the period is 2 pi divided by half, or 4 pi. So it takes 4 pi to cover one full cycle. I also know that I'm shifting left because of the plus, and so I'm going to go left a distance of 180 degrees, and down this time 3. Okay, so again, just listing this off tells me that you know exactly what you're doing. At that point, probably you got 4 to 6 marks or 4 to 5 marks anyways, and the graph is pretty trivial. Now this time, the one difference I'd say, last time I had 3 cycles in 2 pi, so drawing 3 cycles was nice and easy. In this case, because I'm talking about a distance of 4 pi, I want to probably just draw the one cycle. So I'm going to make it a fairly large cycle. And other than the fact that my second half here is a little too long, not terrible. Okay, now again, what do I know? I know that the distance from here to here is 4 pi. Probably a little bit better though to start at my starting point. So I've moved my original graph left a distance of pi, which means that it starts at -pi. If this distance is now 4 pi, that makes this 3 pi. And of course, right in the middle is going to be 1.5 pi, or 3 pi over 2. I also know my amplitude was 4, so my maximum would have been 4, except that I've now dropped down 3, which means that my maximum will be at 1. And my minimum, which would have been -4, is now down to -7. And probably what I should have done was actually put my axes in here somewhere. So let's see, that's pi, that's 3 pi over 2, so pi is right about here, so my 0 is somewhere around here. I don't have to be too good about it. Now it would make sense probably to have put these two things kind of in here. There's 1, there's -7, and then my 0, 1's there, so the 0 axis is, again, somewhere in and around here. And so there's my graph. That one was a little easier than the last one because I didn't have those extreme numbers, but the idea is still the same. You want to make sure that, again, keys, make sure I know you know what you're doing, and then draw in the curve, fill in some key values to show that you have a pretty good idea where it sits, and insert the axes as best you can. So that's one option. The other option was do it the way we had originally. I'm fine with either one, but definitely list off the key information to get the majority of the marks.